In this video, we're going to look at stoichiometric calculations. We're going to look at how we can use stoichiometric ratios to convert within a balanced chemical equation. We're also going to look at the limiting reagents and how to calculate the limiting reagent. If we look at this chemical equation, methanol plus oxygen reacts to give carbon dioxide and water. We can see that this is a balanced chemical equation. And the values 2, 3, 2, and 4 are our stoichiometric ratios. We can use stoichiometric ratios to convert the number of moles of a given substance into the equivalent number of moles of a desired substance. Let's use this balanced chemical equation to answer a simple problem. How many grams of oxygen are required in the combustion of 100 grams of methanol, CH3OH? As we can see in this chemical equation, we have 2 methanols for every 3 oxygens. So if we start working the problem, we'll start with 100 grams of methanol, and we're going to have to convert that into, first, moles. So we'll use the molecular mass of methanol. So we have 1 mole of methanol over 32.04 grams of methanol. Now we'll have it in moles of methanol. We need to convert moles of methanol into moles of oxygen. To do that, we're going to use the stoichiometric coefficients. We have a 2 in front of the methanol, so 2 moles of methanol. And we have a 3 in front of the oxygen, so 3 moles of oxygen. Now, we wanted to know how many grams of oxygen, so now we've got it in moles of oxygen. So we're going to use, again, our molar mass, so 3.1998 grams of oxygen for 1 mole of oxygen. And that'll give us our final value. Now, we want to check, so we have grams of methanol here, grams of methanol there, moles of methanol, moles of methanol, moles of oxygen, leaving us grams of oxygen. We do our calculation, and we'll see that we get 149.8 grams of oxygen. Now, if we look at this equation, we can also use this to calculate the number of moles of a product. So let's use this same chemical equation and look at how many moles of carbon dioxide would be produced by the combustion of 100 grams of methanol in excess oxygen. Now, in this problem, we're going to be looking for moles of carbon dioxide. It's important that I said excess of oxygen. That means the only really value I need to work with is 100 grams of methanol. So 100 grams of methanol, we're going to do the same type of calculation. First, we're going to convert this into moles. So use the molar mass, multiply that by the stoichiometric coefficients. We see that we have a 2 in front of methanol, and we have a 2 in front of carbon dioxide. Therefore, again, check our units. Grams cancel, moles of methanol cancel, leave us with moles of CO2. We do our calculation, and we'll see that we come out with 3.121 moles of carbon dioxide. Now, in this one, we used excess of oxygen, which means we only had one possible limiting reagent. If we look at limiting reagent, what we're going to need to do here is to convert both reactants to the same product and compare the two values. So we're going to look at a slightly different problem here. A mixture of 2.0 moles of carbon disulfide and 3.0 moles of oxygen react to produce 1 mole of carbon dioxide and 2 moles of sulfur oxide. What is the limiting reagent? For this, we need to convert both the carbon disulfide into a product and the oxygen into a product. So let's choose carbon dioxide as our product. So starting with 2 moles of carbon disulfide, again, we're going to convert this. Here we don't have to go through the grams. We can just look at the moles. We do the calculation here, and again, 1 over 1 from the stoichiometric coefficients from our balanced equation, and we get 2 moles of carbon dioxide. We do the same thing with oxygen, 3.0 moles of oxygen. Going to multiply that by the stoichiometric coefficients. In this case, we notice that there is a 3 moles of oxygen for 1 mole of carbon dioxide in our stoichiometric coefficients. Therefore, we're going to end up with a product of 1 mole of carbon dioxide. we convert them both to the same product. Now we can compare apples to apples, and we see we have 2 moles starting from the carbon disulfide and 1 mole starting from oxygen. That means that their oxygen is our limiting reagent. As our limiting reagent, that means that this is going to be the maximum quantity of carbon dioxide we can produce. We actually have an excess of the carbon disulfide. It's often important to start looking at limiting reagents even when the question doesn't explicitly ask for it. An example would be percent yield that you might run into in a laboratory situation.